Hello everyone. Today I am going to giving a presentation on the inorganic chemistry. The topic is coordination compounds. Coordination compound are the compound of metal atom or ion on which ligands atom molecules donate the electron to the metal. Coordination compound comes from the coordination covalent bond, which historically we can consider to form by donation of a pair of electrons from one atom to another. In coordination compound, the donors are usually the ligands and the acceptors are the metals. Coordination compound are the example of acid-base adduct frequently called complexes or if charged complex ions. Werner theory of coordination compounds. Several theories were proposed, but none could satisfactorily all explain all the observable properties of these compounds. And similarly, other series of compound which had been prepared by them, it was only in 1893 that Werner put forward a set of ideas which are known as Werner's coordination theory to explain the nature of bonding in complexes. His theory has been guiding principle in organic chemistry. The important postulate of Werner theory is metal in a coordination compound exhibit two types of valencies, primary valency, secondary valency. Primary or ionizable valence is satisfied by negative ions and the correspond to oxidation state of the metal. The secondary or non-ionizable valency, which is satisfactory by negative, positive or metal groups, is equals to the coordination number of metal ion. Every ion tends to the satisfy but its primary and secondary valency. The secondary valence is directly fixed between in a space. This gives the special arrangement of ligands around the central metal atom and correspond to different coordination numbers. For the complexes like COCl3.6NH3, COCl3.5NH3, COCl3.4NH3, the number of ionizable ions in these complexes are 3, 2 or 1. Respectively, it has been provided precipitation reaction and conductivity measurement on the basis of Werner's postulate. These compounds are formulated as CONH36 whole Cl3. Respectively, the species inside the square bracket being complex outside the square bracket are ionizable ions on the basis of Werner theory's structure. One of the three chloride ions satisfied by both primary and secondary valency. Werner also postulated that octahedral, tetrahedral, and square planar shapes are more common for coordination compound of transition elements. Six coordinated complexes such as NiNH36 whole 2 positive, CONH36 whole 3 positive are octahedral, with four coordinated such as NiCl4.2 negative and NiCN whole 2 negative are tetrahedral and square planar respectively. Important terms are in coordination chemistry: ligands, molecules or ions that are attached to a metal atom in a complex V coordination bond are called ligands. The interaction between a metal or a ligand can be through a Lewis acid-base reaction. As you know, a Lewis base is a substance capable of donating one more electron pair. Every ligand has at least one unshared pair of valence electron. For example, nitrogen in the donor atom and the Cu2 positive is a acceptor atom in the CuNH32 positive complex, and depending upon the number of donor atom present, ligands are defined as the monodentate, bidentate, polydentate. H2 and H3 are monodentate ligand with only one donor in each. Ethylene diamine is a bidentate ligand. The two nitrogen can coordinate with a metal ion. Bidentate, polydentate ligand are called chelating agent because of their ability of metal atom. Example, ethylene diamine EDTA, a polydentate ligand. Coordination number. The coordination number in a coordination compound is defined as the number of ligand or the atom or ion surrounding in the central metal ion, or twice the number of bidentate ligand, or thrice the number of tridentate ligand, so on. Complex ion. It can be defined as the number of coordination bonds formed by the ligand with the metal atom ions. The coordination number of Ag positive in Ag and NH32 positive is 2, and the Cu2 positive in a CuNH3 whole 4 2 positive is 4. Coordination sphere. The central metal atom and a ligand which are directly attached to a enclosed in a square bracket and collectively termed as coordination sphere. The ligands or the metal atom ion square bracket behave as single constituent unit. Oxidation number. Another important property of coordination number is the oxidation number of a central metal ion. The net charge on the complex ion, the sum of charges on the central metal atom in a surrounding ligand in the PCl4 ion. For example, each chloride ion has a oxidation number of -1, so the oxidation number of Pt must be +4. If the ligand do not bear its charge, oxidation number of a metal is equal to the charge of complex ion. Thus in CuNH3 whole 4 2 positive, each NH3 is neutral and oxidation number of copper is 2. Rules for the naming of coordination compound. The rules for the coordination compound is recommended by IUPAC naming follows. The cations in a name as anion in the other compound. The rules hold regardless of whether the complex ions bear positive or negative charge. For examples, K for FeCN6 we name as first respectively. Within a complex ligand are named in alphabetic order. The metal atom is named last. Third, the name of anionic ligand ends with O, whereas a neutral ligand is usually called by its name of the molecule. The exception are H2O, aqua, CO carbonyl, NH3amine. The several ligands of particular kind are present. We use Greek prefix di, tetra, etc. to name the ligands. In cations, CONH3 whole 5, Cl2 whole positive are named as tetramine dichloro. Prefix are ignored in alphabetic ligand. If the ligand itself contains a Greek preface, we use the prefix like bis, tris, and tetrakis to indicate the number of ligand present. For example, a ligand ethylene diamine already contains di. Therefore, if two such ligands are present, the name is bisethylenamine. The oxidation number of metal is written as the Roman numerals following the name of the metal. For example, the Roman numeral third is used to indicate the plus through oxidation state of a chromium CrNH3 whole 4 Cl whole positive, which is named as tetramine dichlorochromium. If the complex of an ion ends with 8, for example K4FeCN6, the name is hexacyanoferrate. If the complex is either a cation is a neutral change required in the name of central atom ion, like CuNH4 3 positive and NiCO4 are named as hexaamine cobalt and hexacarbonyl nickel. Chelate effect. The process in which the occur ring formation in the presence of two or more separate coordination bond between a polydentate and multi-bonded ligand, a single central atom. The coordination complex formed by result of chelation is called chelate, and the polydentate ligand are called chelating ligand. The chelate effect describes the enhanced affinity of chelating ligand for a metal ion compared to the affinity of a collection of a similar non-chelating ligand for a same metal. Chelates are more stable than non-chelated complexes of a comparable composition, and the more extensive the chelation, the number of rings colored in metal ions, more stable the coordination complexes. The phenomena is called chelate effect. It is generally attributed to an increase in the thermodynamic quantity of entropy. The companies chelating, the stability of a chelate is also related to number of atoms in the chelate. In general, chelate contains 5-6 membered rings are more stable than chelate with 4, 7 or 8 membered ring. Application of chelation. Chelate therapy. It involves the using of chelating agent to detoxify poisonous metals. Agent such as mercury or arsenic, lead, by converting them into a chemical inert form. They can be exerted by further interaction with body. Similarly, dipenicillamine with the forms chelate complexes of copper is used to treatment of Wilson's disease. Some biochemicals exhibit the ability of dissolve certain metal ions. Thus, protein, polysaccharide, and polynucleic acid are excellent polydentate ligand for many metal ions. Organic compounds such as amino acid, glutamic acid, and histidine, organic diacids such as malate, polydentate such as polyethylene, such as typical chelators. All metal enzymes features metal that are chelated, usually peptides, cofactors, and proteinic groups. Such chelating agents indicate the propionine rings. Many microbial species produce were soluble pigment that serve as chelating agent. Chelating agents are also employed in extraction in industrial and laboratory separation of metals, such as a metal ion buffer and indicator in analytical chemistry. Chelating complex of gadolinium are often used in contrast agent in MRJ sense, although iron particle and manganese chelate complex also are explored. Effective atomic number. Effective atomic number is the number represented by the total number of electrons surrounding the metal atoms ions in a metal complex. It is equal to the number of electron of central metal ions uh, and the bonding electron from the surrounding electron donating atom or molecule ligand. EAN is equals to Z minus OS plus 2 CN. Z atomic number, OS oxidation state, CN coordination number. Thus, the effective atomic number of a cobalt atom in the complexes CONH363 positive is 36. The number of electron in the trivalent cobalt is 24, and the number of bonding electron from 6 surrounding ammonia molecule. Each of the contributes electron pair 12. EAN rule. N.V. Sidgwick made the observation since known as EAN rule. Then in a number of metal complexes, the metal atom tends to surround itself with sufficient ligand that the resulting effect atomic number is numerically equal to the atomic number of noble gases element found in same period in which the metal is located. This, according to a EN rule, a metal ions is complexes accept electron pair from the ligands until it achieves the next noble gas configuration of the same period in which the metal is located. This rule seems to hold for the lowest of metal complexes with carbon monoxide, the metal carbonized, as well as the orgo organometal compound. By using this rule, it is possible to predict the number of ligands in these types of compound, also the product of their reaction. The EAN rule is often referred to the 18 electron rule, since if an accounts valence, the total number is 18. Isomers in coordination complexes. Compounds that have the same chemical formula but different structural arrangement are called isomers. Because of these complicated formula of many coordination compounds, the variety of bond type, and the number of shapes possible, many different types of isomerism occur. Werner's qualification as depicted below is still generally accepted. Structural isomerism. Ionization isomer results from the interchange of an ionic ligand within the first coordination pair with an anion outside the coordination pair. Hydration isomer result from the interchange of hydrogen H2 hydrogen oxide water H2 and another ligand between the first coordination pair and the ligand outside. Linkage isomers arise when one or more the ligand can coordinate to the metal in more than one way. Additional examples CONH3O5ONO. Coordination isomers only possible for salt in which both cations and anions are complex ion. The isomers arise from interchange of ligand between the two metal centers CONH3Cr and X6. Bonding in coordination compound. Valence bond theory. Linus Pauling ideas but about bond theory had been applied to coordination compound. This theory can account reasonably well structure and magnetic properties of metal complexes. The basis principles which are involved in the valence bond treatment of coordination compounds, hybridization of valence orbital of central metal ion, bonding between the ligand and the metal ion, relation between the type and bond of the observed magnetic behavior. Step involved: write down the electronic configuration of metal ions, find out oxidation state of metal ion atom, write down the electronic configuration of metal atom, write down the configuration of complexes to find the hybridization. Strong field ligand can preparing the electron, strong field COCN negative, NO2 ENPYNH3, weak field ligand OH H2O F Cl negative Br negative. When the d orbital taking part in hybridization is inside the S and P taking part in hybridization with respect to nucleus, it is called the inner orbital complex. Example 6 coordinating complex. Let us simple example of SCO4 F6 3 negative. Also in the bond complex oxidation state of cobalt COF4 6 is paramagnetic. Firstly, the appropriate ionized takes CO3 negative cobalt has atom other outer electrons 3d 3d74s to the CO3 negative and will have the configuration 3d6 electron will be arranged. CO3 negative both paramagnetic diamagnetic inner orbital complexes depend upon the nature of ligand is illustrated below as CO3 negative CO3 positive ion combines with the 6 fluoride ligand or in COFX6 3 negative empty atomic orbital are required on the metal ion receive the coordinated lone pair of electrons. The coordination used 1,4s and 3,4p 2,4d. These are hybridized to give a set of 6 equivalent sp3d2 hybridized orbital, a ligand orbital consisting a lone pair of electrons from coordination bond by overlapping with an empty hybrid orbital on the metal ion. The d orbitals use their 4dz square and 4dx square minus y square. Since inner 4d orbital are used in boiling, this is called the outer orbital complex. The energy of these orbital is quite high, so complexes will be reactive. This reactive will be high spin paramagnetic because it has 4 unpaired electrons. An alternate octahedral arrangement is possible when electron metal ion are arranged. These are the given structure for the NiCl4 2 negative. This is for Ni. This is for Ni2 positive. This is for NiCl4 whole 2 negative, and the third is NiCN4 whole 2 negative, Ni2 positive, NiCO4 2 negative, and this is NiCO4 examples. Now the application of coordination compound extraction of metals. Cyanide ions are used for the extraction of gold and silver. The crushed ore is heated when the aqua cyanide solution in the presence of air to dissolve the gold by forming the soluble complex ion AuCN whole 2 negative 4AO plus 8CN plus 2O2 plus H2O plus 4AuCN2 negative aqua plus 4OH negative zinc plus 4 plus 2 AuCN2 negative ZnCN4O2 negative plus 2 Au complex formation is also useful for purification of metals. Nickel is purified by the converting the metal to gaseous compound NiCO4 and then decomposing the later to pure nickel. Medicines: EDTA is chelating agent which is used in treatment of lead poisoning. Cisplatin PTNH3 whole 2 Cl2 is used in treatment of cancer. Sodium nitroprusside Na2FeCnO5 NO is used to lower blood pressure during surgery. Qualitative analysis: separation of Ag2 positive and Pb2 positive and Hg2 positive. Ag positive plus 2NH3 gives AgNH3 twice and whole 2 positive. Separation of second A and second B groups. The cation of second B groups from soluble complexes with yellow ammonium sulfide. CO2 positive form complexes and addition of ammonia, CO, NH3, 4, 4, 2 positive. Thank you.